Today we're going to look at a situation where a ball on a string is spun around in a horizontal circle. Now, when something is spinning in a circle, you know that if it's moving in circular motion, it has to be accelerating because its direction is continuously changing. And one question that you'll have is, which way is it accelerating? Remember that if it's moving in a circle, it's actually accelerating toward the center of that circle, because because at any point in time the object is actually, its velocity is actually tangent to the circle, and so its acceleration then is going to be toward the center in order to keep it going around in a circle. Alright, and so we've got this particular ball is spinning around in a horizontal circle of radius 0.950 meters. The 400-gram ball makes a circle every 1.5 seconds. And we want to find the velocity, acceleration, and net force acting on the ball. Alright, well, let's write our givens down. Let's see. We've got that the object is going to be spinning around in a circle, so let's see, we'll make a circle for it to spin in real quickly. And the object itself we'll just represent right here. And we know that its velocity at any point in time will actually be tangent to the circle. And so we'll represent that right here. There we go. And so that's the velocity of the object at any point in time as it's traveling around the circle this direction. Alright, and so I'll label that with a tangential velocity. If we're asked to label the acceleration, of course that would be pointing toward the center of the circle, something like this. And that would be the acceleration at any point in time, always toward the center. Alright, so the mass of this object is 400 grams. Now that is a non-standard unit, and so we need to immediately, let's convert that into our standard unit of kilograms. Remember that for kilograms we're going to move that decimal 3 spots to the left. That is, we're dividing by 1,000, so that's going to convert to 0.400 kilograms, and it has a radius of 0.950 meters. That is a standard unit, so we're in good shape there. And let's see. Oh, and it makes a circle every 1.5 seconds. Alright, so you might say to yourself, okay, that's the time, because seconds measure time. Well, that's true, that is an amount of time, but in this case that is going to be the time for one trip or one full lap of the ball around the circle, and so that's going to be its period, the time for one cycle, and so we'll represent that with a capital T. Alright, great. Well, the first thing we want to find is its velocity, and its velocity can be found from the relationship of distance divided by time. Remember that the distance in this case is the circumference, and the time is the period, the time for one lap. And so we'll substitute 2 times pi times 0.950, and all of that will be divided by the period, which is 1.5 seconds. Alright, and then get your handy dandy calculator out and punch those numbers. And when you do, you'll see, I get something around 3.98. That is a rounded number, but I got 3.98, and the units, since it's a speed, are in fact meters per second. Well, great. Alright, next thing on tap is the acceleration. Now that is actually going to be, remember, the centripetal acceleration because it's acting toward the middle, and that will be found from taking our velocity, our tangential velocity, squaring it and dividing by the radius. So let's see, put that in there, and I'm not actually going to use my rounded value. I'm going to click up on my calculator and pull down the previous answer. Don't forget to square it and divide by the radius 1.5. And when you do, click, 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 you'll find that that answer is, let's see, I'm getting 10.56. Again, a rounded value. Yeah, 10.56. And the units for all of our accelerations are meters per second squared. So let's get that boxed in well also. Don't want answers running around willy-nilly all over the page. Box them in. All right, and so let's see. There we go. And now we'll find the net force. The net force in this case is actually that force which is holding the ball in the circle, and that's toward the center as well. That's the centripetal force. The centripetal force is the net force in this case. And so that will be found from F net equals m times a, or Fc equals m times ac, since the net force is the centripetal force and the acceleration is the centripetal acceleration. So Fc equals, let's see, mass is 0.4. And again, our previous answer, 10.56. And so the centripetal force then comes out to be something around 4.2 newtons. All right, and that's all that there is to it. I hope that was helpful.